My name is Ben Caro. This talk is about Novena, which is a hacker's laptop. If you guys in the back might want to stand up a little more, there's one in front of you. If you don't want to, you can come check it out. After the talk, I understand there's a lot of time. This talk runs right up to lunch, so I'm going to try and get out a little early and give you guys a little longer lunch than 45 minutes. Blank slide. So this is for those of you who want to make sure you're in the right place. This is about this piece of hardware and the not only the hardware, but the project behind it and the software and kind of how the project is managed. It's a fully open source laptop. It's got an unconventional form factor. I'll get into it in a bit. It's kind of aimed at power users. There's a lot of attention to detail for things power users might find interesting or cool. And its primary purpose, like the inspiration behind it, was for security researchers or electrical engineers to have a piece of hardware that they could carry around that would be like the equivalent of a workstation where they had all their equipment to do testing of individual like hardware pieces. So before that, a little bit about me. My day job is Linux. I'm an engineer over at Red Hat, so I do Linux a lot. My hobby is embedded Linux. I guess I'm kind of boring. But I really like weird pieces of hardware. This is a pretty weird piece of hardware. And I can get into kind of the backstory of it a little bit. I was a Novena backer. This was originally a crowdfunded thing. Now you can just go pick up the boards and all the pieces. But originally, they needed enough, basically enough scale to be able to make the boards correctly and to be able to go through the effort of doing things like designing the screen bezel, stuff like that. I also got involved in the project. I joined the community, and I contribute some software patches back upstream, and I can tell you how in a little bit. So let me just start with the origins of the project. This is kind of where you start with. So there's two main contributors. This guy on the left is Bunny. He's a classic hardware hacker, graduated from MIT in the 90s, and he does a bunch of, his specialty is kind of open source hardware bits. So he did Chumby, if you guys remember that. It was just this kind of adorable little embedded Linux computer in a really squishy case so you could throw it around, and you could program it to do things like tell you the bus schedule, and it was pretty basic, but a really cool project. And he joined up with one of his friends, Zobs, Sean Cross, the guy on the right, and they founded this studio or company just specifically for open hardware projects. And the Chumby was one of those, and this is probably the third or fourth iteration on things they've done. They also do some really cool things, like for kids they have printable circuits. It's not a very good way to say it. They made a sticker book that is just printed circuits, so you can pull them out of your sticker book and stick them together on a sheet of paper and make circuits to light up lights and really cool stuff like that. So for people who are just learning electronics, it's a really cool way to go about it. They're based out of Singapore, so they have some interesting challenges based on humidity and stuff like that. But they always wanted to build a laptop, and they wanted to do it because growing up, they kind of had the expectation that you can just get all these pieces. You get the motherboard, you get the memory and the hard drive, and you can build a desktop. Why can't you do the same thing with a laptop? Well, it turns out there's some integration reasons, and like trying to fit them all in a small package is kind of difficult. But they got degrees, and now they can overcome those things, and and now it's possible. And with a lot of the ARM single-board computers out there, the design of these boards isn't that much different. So like a Raspberry Pi, for example, you can do this with. There's like the Pi Top that was mentioned earlier. There are other projects that are coming about like this too. SmartBook was one that was just announced yesterday. NextDock is another one that you can plug your phone in, turn it into a laptop. You can also just plug an ARM computer in there and do the same thing. So they use this website called CrowdSupply to do it. It's basically Kickstarter or Indiegogo. they got more money than they asked for, which is how these things go. And that's about it. They had a couple stretch goals, which are really cool, that I'm going to get into in the software section. I'm really glad they did, because they made this thing a lot better, and they made Linux on ARM a lot better, too. But first, the inspiration for this was this is what normal laptops are becoming. I don't know if this slide needs a lot of explanation, but just for completeness, I'm going to do it anyways. The cutaway of the laptop here, this is actually the latest iteration of an Apple MacBook. And it's a beautiful piece of hardware, 1.8 pounds, it's one of the lightest things out there, but the problem is connectivity. Besides the headphone jack on the other side, that's the only port on this thing. So if you want to do something like plug in a USB drive, you'll have to get an adapter. If you want to plug in a USB drive while you're charging your laptop, you can't, because there's only one port. And that's not fair. You can buy a hub, but then you have to carry the hub around too. So this is obviously an extreme example, but this is kind of where things are going. We don't see serial ports on laptops anymore. You don't see parallel ports to plug in old printers. You see less and less USB ports. It used to be like when ThinkPads 3 years ago, they had maybe 4 or 5 USB ports, and now they're down to just 2. And that's obviously great, because you usually don't have that many things plugged in, but there should be something else. There should be something that will cater to users who want these ports. So not only USB, they want other ports too, like Ethernet is becoming rare. And besides the ports, there's a problem with the freedom on the laptop too. And that is that all of these pieces of hardware are becoming less and less free, especially in the Linux kernel. So what's been happening is that, let's take the Wi-Fi card, for example. The Wi-Fi card went in this, and in this is made by Intel, and that's wonderful. Intel does a great job of writing these drivers. But recently what's happened, among other reasons, cost-cutting, is that they say the driver's going to be completely in the Linux kernel, but we already have this blobby piece of memory that is how the card should look when we bring it up, when we actually boot up the wireless card in your system. So instead of writing all of this initialization code for booting it up with source code, we're just going to inject this blob in there. And the problem with these is, even if they're released under an open source license, you can't do anything with that. There's no bugs to fix unless you're going to reverse engineer the actual contents of memory. And so, beyond wanting to be an open source laptop, they want it to be a laptop that you can kind of reverse engineer. So they don't include blobs like that, and they made sure that all the pieces in it have basically NDA-free data sheets. So like if you go and you want to improve the sound chip on it somehow, you actually look at the sound chip and find the model number on there, and you go type that model number and say data sheet. And sometimes you'll go redirected to TI or Realtek or something, and they'll say you need to sign in with this account and sign this contract before we'll let you see the data sheets. And as a hobbyist, there's no way you want to do that. For some things, they cost tens of thousands of dollars, and others, unless you're a company, they just won't give it to you. And so that's where the vision of the Novena came in. They didn't want to have anything to do with that. They wanted to have something that they could take with off-the-shelf components and basically open source methodologies and ideas, and make a hardware platform that they would want to use every day. So getting back to like who this thing is for, it's not the only open source laptop out there. There's the Librem project, which came around, which is a little more of a mainstream focused piece of hardware. But for this is everything like a hardware hacker could want. It's got FPGAs, which is a piece of hardware that allows you to design new microchips in software, which is really cool. So you aren't even limited by the architecture of it. It's got a software-defined radio, which is basically this magic wand and allows you to do anything you could ever want with radio. And I'm going to give some examples of this a little later that might be the word extra legal. That doesn't mean it's super legal. It means the opposite of that. It's got UARTs and JTAGs. UARTs are basically the modern equivalent of a serial port without the actual port standardized on it. And the surprising things is, even though serial ports on laptops went away, serial ports on hardware have totally not gone away. Like that projector up there probably has a serial port on the back of it, and that's how it's controlled with all this stuff up here. So if you're a hardware hacker and you want to do something, if you want to talk to that thing, you obviously need some way to talk serial. And if your laptop doesn't have it anymore, you need to go buy adapters and then carry the adapters with you. And oh no, I left it at home. What am I going to do? I guess I'm not going to fool around with the university's projector today. Another cool thing they did was they included dual Ethernet on it. So I can turn this thing for the benefit of the people in the front, but there's 2 Ethernet ports on the front. And there's a very good reason for this. Is if you're doing security research, you want to be able to isolate the thing you're testing. You don't want to give it like public access to the internet and then sniff alongside it. You want to be right there in the middle. And you guys, you'd be surprised at the amount of like terrible unsecured crap that all this new Internet of Things devices are spitting out. Like light bulbs, like basically advertising state across the internet, unencrypted, is no bueno. And it's just going to get worse and worse. I don't want to know what my fridge is tattling about me on the internet. Maybe I'll lose my warranty if I leave the door open. So, yeah, they wanted everything to have blob-free drivers, like blob-free Wi-Fi. And they, what does that say? They wanted it to be kind of an interesting form factor. So the idea behind this case and its kind of backwards laptop-ishness is they wanted to, I guess, make people more aware of open hardware and to kind of start a conversation. So if you saw something like this in a coffee shop, you might think it was a little weird and ask, oh, what's that? And then you could have this conversation about free hardware. And have you heard of this Linux thing? It kind of goes along with it. You can put it on your laptop too. And then everyone's an advocate. So this, I'm not going to spend too much time here, but this is maybe one of 2 circuit boards you'll see, and you obviously don't have to read this. This is kind of the port manifest. So like here's, God, USB ports, I don't even know. They're probably over there somewhere. But yeah, this is kind of what it all started on. And this was, you can use it as a desktop too. They sell these as desktop boards. And then you can plug a battery board into it, and it's basically a laptop. Compared to like something like a Raspberry Pi, you have a couple differences. So like this thing, you can put your own memory in. So you want to upgrade it to 8 gigs of memory? Go ahead. Which is really useful, and not something that you see a lot on ARM boards these days. And everything is upgradable, and it's cool. So they did this. They did this hardware project, they did the crowdfunding, and then the result of it was actually really surprising. This was the first time I've ever seen a hardware, like, crowdfunded project actually succeed and deliver everything and deliver on time. Probably backed way too many hardware projects, and I'm emotionally invested in them now, and I just know that 3/4 of them are never going to come out. It was awesome. They delivered a quality display. Since they use it themselves, they didn't want to look at terrible low-resolution displays, so it's a 1080p panel. It's like a top-tier laptop display, and it's, if you can tell, it's a bit delicate. It's kind of meant to live on a workbench. I have a special backpack for bringing it here and bringing it around because this is the keyboard it comes with, and it doesn't cover the whole screen. So you can kind of poke the LCD, and LCDs don't like being poked. So it's a bit delicate. It's kind of meant to live on a workbench and or live in kind of a special backpack. But it's got some kind of cool components. So like if you have a fancy car or a car with a really heavy hood, I guess, you have a gas strut under there. So if you pop the hood, it just kind of slides up on its own. And they decided to do the same thing with this. I don't know if they meant it to be like a Cadillac or something, but yeah. Since they use Linux, everything comes pre-installed with Linux. Everything works because that's what they're targeting. That's what they're testing against. So it shouldn't be surprising. One of the things one of the stretch goals that I wanted to touch on from the crowdfunding project was they said if we get an extra, I think it was $25,000, we'll hire the dude who makes open source drivers and just make him work on this and make them and pay him to make ARM video work as good as Intel video, which is awesome because if you've been following ARM Linux computers for a while, you can. One of the big problems is that the video drivers just aren't very mature. Like even doing something like playing a video can make it slow to a crawl. Some hardware acceleration is good for that, but like if you try and render a video in software on a Raspberry Pi, you're gonna have a really bad time. But now it's actually pretty good and it's usable for a desktop. I want to talk about software a little bit on it. It originally shipped with Debian Jessie, which is the latest version of Debian, or maybe not anymore. Is it still the latest?
Yeah, it's
yes?
the latest stable.
Latest stable, okay. It ships with Debian Jessie stable. And they did a really good job of it. They don't have special repositories for you to go get packages. They just use Debian stable ARM packages. And they have a special repository for just the packages. So, for instance, there was a firmware update for the battery board on this thing, and that just came out as a package in their special repository, and there's nothing else in there. And that's the only thing that makes it different than just running Debian on your laptop. And they did this correctly, so they have a secure signing key. They sign all the packages that come out of them. They've actually been... Zobs, Sean Cross, is the guy who makes these packages usually. And he complains on his blog quite a bit that the secure signing key might be a little bit too secure. They keep it in an air-gapped computer that is never, ever connected to the internet. And the problem is that they don't have a clock. Like, they don't have a battery to save the clock on this thing. So when they they shut it off and turn it on again, the time resets. And when they try to sign packages in, like, January 1st, 1970, it yells at them. So he made a new repository called the Beta repository, which is a little less secure, but we're getting packages a little faster now, so I'm happy with it. All the documentation is on the wiki, so you can go to kosagi.com/w, and all of the documentation is on there. You can see, so I got this, what is this thing? Yeah, I got this picture on there. There's beautiful high-resolution pictures of everything on there. There's documentation for the boards. I just booted this thing up. How do I connect a Bluetooth keyboard? That kind of thing is on there. So I think I'm done talking about the software that comes with it. Now I kind of want to talk about some of the stupid extra-legal things you can do with it. So can anyone tell me what this is? Yes, this is Ingress. This is actually Bellingham. Not actually. So BTC is on here somewhere, and I'm betting it's in one of these clusters of little blue dots, or little green dots. Sorry, I'm colorblind. So the concept of Ingress, it's this game that you play on your cell phone, and you're one of two teams. You're the blue team, called the Smurfs, or the green team, called the Frogs. And it's overlaid on a real map, and each of these little points there is a portal, and your goal is to capture the portal for your team and prevent the other team from taking it. And the way that your phone does this is with the GPS. It's literally an overlay on Google Maps. Google has subsequently bought the people who made this game. And you have to physically walk within, 50 meters or something of it. And then you can capture it. And so one of the cool things you can do with a Novena is you can use the software-defined radio, and you can say, okay, tune in to, I think GPS runs at 500 megahertz. So tune into 500 megahertz and listen for the GPS signals coming from these satellites and interpret them and tell me where I am. That's kind of cool, but my phone can already do that. It has GPS built in. One of the things my phone can't do is that this thing can is also transmit. So there's this cool piece of software out there called GPS SDR Sim for simulator that will actually output fake GPS coordinates to everything around you. I decided it would be a bad idea to do this now in this room, but if I did, I could say, everyone pull out your phones and open maps, and you would be in the middle of the Pacific Ocean or something. So using this, you can kind of cheat at this game. So if you don't want to walk to the portal down the block, you can just set the software to say you're at the portal down the block. So that's kind of fun. The next project is an FM radio, and I couldn't find really good pictures of, Creative Commons licensed pictures of a radio, but I did find this, which is a really cool old Panasonic radio, and it says something cheesy like, when you're thin and elegant, people take you everywhere. You can use a software-defined radio to tune into FM frequencies and listen to music or listen to AM radio or whatever you want to do. And that's kind of interesting, but you can also use it to connect to multiple stations since it's called the sampling frequency. It's basically how fast it can listen to things. And it turns out it's so fast that you can listen to multiple radio stations at once. Not that that's much good, because you can only hear one radio station at once while still trying to maintain your sanity. But it can also transmit radio, so you can run a pirate radio station if you want. There's this really cool piece of software called GNU Radio, and I could show you a screenshot, but they're really boring. They're basically like the flowcharts, and the text is so small no one could read it. I can't even read it on my laptop from here. So instead, I'll show you this cool thing. But one of the interesting things is you can run a pirate radio station, but you can also run a not pirate radio station. Did you guys, before aux jacks were cool things in cars, did you ever have one of those, you plug it into a microphone or a headphone jack, and it had a little FM transmitter in it, and you turned your frequency of your car to that? Yeah, there's one specific frequency where you can actually do this legally. So you could, for example, set this up on your laptop and pipe VLC to it or pipe some other music player to it and just run a little temporary radio station wherever you are. I thought that was kind of cool. I also thought Unicode was cool, and this was about 2 a.m. last night, so I thought putting in little Unicode symbols on the title was really cool. Which brings me to my next slide. You can also do similar things with cell phones. Also banana phones. One of the cool open source projects you can run on these, and you can run on other hardware too, is called OpenBTS. And it's basically, it's a way to run your own cell network. And it's totally legal to do this, as long as you do it on frequencies that are open to the public. It turns out 900 megahertz is open to the public. It's amateur band. I'm sorry, I'm sure there's radio people in the room who will correct me on this. But yeah, this is what cordless phones used to be before they moved to 2.4 gigahertz. They can handle multiple headsets. You can do SMS over them. You can do some pretty slow data, but you can still totally do data over this. Do you guys know what Burning Man is? Yeah. So one of the things that happened at Burning Man is the people who made this software, OpenBTS, they go to Burning Man too, and so they are the people who run the cell phone network there. So there's one camp at Burning Man, and you can probably take a burner phone, there, and they'll give you a SIM card, and they'll say, "What do you want your phone number to be?" And you'll say 666 because that's really cool. And then they roll their eyes and give you the SIM card and put you in their network, and then you can call or SMS anyone else at Burning Man. They're really easy to find. They're the people who have the giant antenna. But yeah, with a Novena, or I think you can get some software-defined radios for maybe $80 now. You can do this as a project. I thought this was really cool, so I have fooled around with trying to get my own cell phone networks up and running. They're really good for like emergency preparedness situations or in the wilderness. If you want really long-range radio and for some reason you're not just using regular walkie-talkies. The next one, DIY processors, FPGAs. It's literally this chip right here. Actually uses a different chip, but it looks exactly like that. And they're really cool chips because they do something unique. They allow you to, this is going to sound really silly, but they allow you to define what they do in software. And you'll tell me, but don't all processors do that? We give them instructions and they run them. But I say, no. There's no base set of instructions in this thing. You get to write your own instructions. So you get to like write your own architecture, which is really cool, and it allows you to interface with really, really weird hardware. So this is how, like, for example, Intel or anyone else makes a chip, is they design it in software first, and then they prove that this is a good way to make a processor, and then once they do that, it costs maybe like $750,000 to actually turn this thing into a dedicated piece of silicon. So obviously they want to do it with software first, and then once they've ironed out all the issues, they turn it into a piece of silicon and crank up the speed. You can do some silly things with this, like mine cryptocurrencies. So for Bitcoin, for example, once desktop processors weren't fast enough, and once graphics cards weren't fast enough, people started writing custom architectures to mine Bitcoins, and they used chips like these. So you can do some silly things like that. And the last thing you can kind of do is, because this has a couple input and output ports on it, you can actually hook up a little resistor and then have video output. So like the old yellow cable RCA that you plug into a TV, you can do that, and you can do real-time music visualizations. So you have the music coming in one or two analog channels, and then you can turn that into visualizations. And you can do that really fast, which makes, you can do that faster than even desktop processors or graphics cards, which makes these things really cool. So I think that's about enough of the projects that I kind of do with it. Some of the projects that spun out of these, so beyond the laptop and beyond the motherboard that came with this thing, there's a couple other things that people really liked and have started using these in other places. And this is one of them. This is the embedded DisplayPort board. So EDP is embedded DisplayPort, and they're really useful for retrofitting screens to old laptops. So even some laptops these days use a different standard for it. It's literally the connector in the protocol that the motherboard uses to talk to the screen. And one of the problems is that they changed that around maybe 2012. So it's really hard to use a nice high-resolution screen with an older computer. Except some people like me really love their older computers and want to put a newer display in it because it's perfect besides that one thing. So since this design is open source, people have taken it and they've said, all right, they've made kits out of it, so they can say, all right, you have an Apple MacBook made in 2008, and we know they didn't come with high-resolution displays, but we can sell this with a display and some instructions, and you can stick this in the case, and you can use a high-resolution display, and hooray, your thing is much better. So that's one of the things, and these have basically found a life of their own. So there's more of these out there than there are Novena laptops these days, because people put them on other machines. The other one thing that came out of it, in terms of hardware, was the battery board. This is the only other circuit board you'll see in here. Before this project, there was no open source like battery board solution out there. So if you wanted, this sounds like a really simple thing and something that should have been solved a long time ago, but if you want to make your own laptop, how are you going to power it? You can stick an AC adapter on there, and then do that. But if you want to move it, you have to unplug it, and obviously your machine's going to shut off. And if you want to use a battery on there, you can do that, but you need some way to charge the battery, which is non-trivial. And you need some way to switch between AC power and battery power. And it turns out that was a pretty hard problem that no one had really solved and released. So they did. And you can go on the forums and just pick these things up and use them for other laptops too, if you want to build something yourself. So moving on, this is the current status of the project. The repositories with all these packages are kept pretty up to date. 3 weeks ago was the last time they were updated. Like I mentioned, there's a beta package, so hopefully packages can come out even faster now. And I'm happy to say that the crowdfunding stretch goal for making better graphics drivers has paid off. So now there's an X-specific driver specifically for these sets of graphics chips, and there's a kernel-level driver that works pretty well with it too. And it works in Linux and it works in Android. Yeah, if you guys have questions about that, the guy who writes this just hangs out on IRC all day, and sometimes he seems pretty bored. So, yeah, if you want to get into graphics programming, it's an awesome opportunity. Makers continue to use these things, and I'm going to show that in a bit. So there's this guy named Ben Heck, and he has this show, it's some web show, I think, on Element 14, which is the Raspberry Pi people. But he bought the motherboard by itself, and he made his own laptop out of it with 3D printed parts and just kind of sourced parts from other things. So there's people who continue to make things out of it, and do things with it, which I think is really cool. As far as the community, there's independent blags. You can search for it. There's unfortunately nothing like a Planet where you can subscribe with your RSS reader or something else to keep up to date with the news. You can go to the forums. They're pretty low traffic and they're newbie friendly, so you can just poke around there if you want. There's an IRC channel that you can join if you want to, if you have any more questions and I can't answer them today, or if you want to start participating in the project. Current community projects. This is the laptop I was talking about. Sorry, it's not that easy to see. Wow, yeah. So there's a whole video series on exactly how he made this, too, which I thought was kind of interesting and is enjoyable to watch. So he decided things like, I want to have a mechanical keyboard in there, and I should be able to lift it up and see the access to everything. So that's one of the cool things that he's doing. People are making cases out of, like, bars of aluminum and piano hinges and stuff like that. So it's really whatever, basically the sky's the limit. And this project kind of attracts some pretty interesting makers who have ideas for projects. So there's obviously cases. There's also alternative displays. So instead of things like LCDs, some people want daylight readable displays. So they're messing around with e-ink screens from like Kindles. So a lot of people have Kindles and they've either replaced them or something broke on them and they don't know what to do with them anymore. It turns out these screens are really useful for, even though they don't have a very high refresh rate, they're really useful for daylight reading. So if you want to be on IRC or something like that, you don't need a really high refresh rate, and if you want to be outside, you need something like high contrast. There's also another project who put, they're called transflective screens. They were originally in the OLPC, and they allow you to flip to another mode that's daylight readable or flip to a mode that's a traditional LCD. These things aren't around anymore, sadly, so you kind of have to scrounge them up on eBay, but that doesn't mean people don't try. And that's kind of all I have. That's where the project is now. So, yeah. Thank you, guys. Are there any questions?
Yeah, how is the release of the new 64-bit ARM processor affect the revision that's out to them? Or waiting on that?
So the question is, how do the 64-bit ARM processors affect this? And the answer is not that much. The board schematics are open source, and it uses processors by a company called Freescale. They're called IMX6 ones. And the cool thing about those is that you can upgrade between ones in the same line without changing anything else on the board. So if they wanted to do another production run of motherboards, they could easily say, let's put the 64-bit one in, and then release those. But it's hard to do with a scale of 1. Any other questions? Yeah. Yeah, you're welcome to come up. The question was, do I have one of the boards, and can you see one? Yeah, you can totally come up here and look at one afterwards if you want. They get kind of toasty. But yeah, they're about that big. Any other questions?
So as far as cases go, is that like a standard offering, or?
Yeah, the question is the case that's in the presentation, the one you see before you, is that the standard case? And yeah, this is the one they shipped to backers. But interestingly, this wasn't the one they prototyped in. They actually used a book binding. So the people who made these things really love leather books. And so they literally like took the LCD and they screwed it into the paper filling for the leather book binding. And then they put some standoffs in there and they put all the hardware in and they could carry it around like a book, and it was really cool.
What's the aggregate cost for building one? Do you buy one pre-assembled, or you can like pick and choose parts?
Yeah. So the question is, what's the aggregate cost of building one? And you could buy one pre-assembled. Actually, you couldn't buy one pre-assembled during the Kickstarter. It came as a kit, and so the case came different, or the case came separately, and the battery came separately, and the motherboard came separately. And you followed the instructions on the wiki, and it told you how to mount these things and put them together. The crowdfunding picture at the beginning, that page is still up and allows you to, unlike a regular Kickstarter or something like that, it allows you to just buy the individual components. So you can buy the laptop kit, which is about $550, and you buy the case, which I think is another $100 or $200, and then you have enough to put it together and just build it yourself. Yeah.
If I ask you nicely, I please have the benefit of your informed thoughts. I'm upgrading my stupid little, 8-year-old Frankenstein PC. You know, when I look at the new specs out there for hardware, woo, it's really fast. Back doors out the wing line, like AMD, Intel,
Yeah.
If I wanted to, look what you guys have, upgrade that, how practical? Because I'm fine with Linux, but, would that be a realistic increase in privacy for me, or would there be a speed compromise, or, what should I know?
Yeah. It's a hard question to answer. It's a little off topic for this, but I'll answer it anyways. The question is, if I want to upgrade my PC, do I upgrade to something like this, or do I upgrade to a new PC? And it's really up to you. There are some conspiracy theorists out there that say that the Intel management engine chips in anything created in the last 5 years. We don't know what it does, and it's all signs. So it could be a backdoor. We don't know. In reality, there's not much alternative besides buying more 8-year-old machines on Craigslist for years and years. I think that it is worth upgrading if you need to upgrade. If you're happy with your computer, that's great.
I apologize. What are you guys doing for the CPU?
ARM.
There's probably no management engine in the ARM.
Nope. It's just a system on a chip, which means it's sound and processor and disk controllers and everything is on a chip.
So would that be an option instead of going to Craigslist and buying 8-year-old stuff?
So the problem with ARM computers is that everything kind of comes bundled on a board. So you don't necessarily buy a processor, you just buy a whole board, like a Raspberry Pi, for example. Comes with everything, and that could be an option. Have you looked into Raspberry Pis?
Not much. Maybe I should.
Yeah.
All right, thanks.
Mm-hmm. Yes.
Last time I checked the repo, the stuff in repo, there were no signatures on the signing key. Has that changed with the recent update?
I haven't checked to see if who else assigned their signing key. I don't know. I do know that they basically post their signing key to the wiki.
Yeah, the wiki without SSL.
Yes, there is SSL, but it's yes.
I'll get after this.
Yeah. Yes, if you just go to the presentation on the LinuxFest Northwest, if there isn't a link on there already, there will be soon. Yes.
Are you aware of any plans to revision the motherboard again to include an FPGA with an open toolchain? Because this FPGA did not.
Yes, you are entirely correct. The good news is you don't need to. So let me scroll back here to the picture of the motherboard. Where'd it go? Yeah, there it is. Okay, so this is a really terrible contrast because it's really bright here. But there's a bunch of pin headers right here, including a Raspberry Pi compatible one right here. That's not there in the final revision. Instead, there's a socket, and the FPGA is actually on a separate socket. So you could just make a new daughter board with an FPGA with an open toolchain. Yes.
For battery input, what's the, are they just using typical 4-cell patterns?
It supports, yeah. The quick. Oh, go ahead.
What are people typically running for capacity? 4,000, 5,000?
Yeah, so the question is, what kind of batteries are people using, and what's the typical capacity? So this isn't actually doing anything since I unplugged it to bring it here, but let me unplug this and show you. Like I said, it's an RC car battery, and it supports anywhere from 2 series to 4 series. So it supports 2 series is 7 volts to 4 series is 15 volts, basically. And there are RC car batteries. They actually do balancing on the controller, which is really cool. And it comes with a 5-amp battery. It actually comes with a custom-made 5-amp battery that is thinner and fits in the case. I didn't know this. I bought a replacement battery. Can't close the case anymore.
I know the controller is pretty solid as far as keeping the battery balanced.
Yeah. They use this chip made by TA called a gas gauge, a fuel gauge, and that actually does it monitors the. So for the benefit of other people, balancing a battery means there's inside this battery there's actually 3 separate pouches, and sometimes these pouches they're each 3.7 volts, and sometimes they can have variations between them. And what balancing is it basically discharges or charges between the separate pouches to try and even it out. Because the problem is if one discharges more than the others, sometimes it can over-discharge and cause a short, and if you ever see these batteries catch fire, that's one of the reasons. Yes?
How much RAM can you integrate into this? Is there
Yes. Actually, if you come up here afterwards, they just use like a Samsung Evo SATA SSD that they got off the shelf. And they come with 4 gigs of RAM, which is the maximum for a 32-bit system. So if they ever did like the person next to you suggested and put a 64-bit chip in, they could easily fit bigger sticks in there. Mm-hmm.
So all of the electronics FCC certified, or is this considered a kit?
It's a kit.
Okay.
They didn't go through the
So
certification.
what do you have to solder?
Is that the definition for a kit? You have to
Generally speaking, that you have to at least assemble at least a component.
Yeah.
I was curious on how they got around it.
It might be the screen.
Oh, okay.
The screen came separately. You needed to. There's actually a bunch of little Allen screws on that you need to screw on and put the little connector onto the board.
It didn't come with a battery, I think.
Oh, it did, but it was in a separate case. But yeah, they actually shipped from Portland. So yeah, for the benefit of other people, it was does this thing come as a kit or does it come pre-assembled? And it comes as a kit mostly because they didn't have to like send it to the FCC and have the FCC hit it with a hammer for a long time to make sure it's safe. So if it comes as a kit, you have to put it together a little more, but it's a lot quicker and a lot cheaper to get to you. Okay. No other questions? I guess I'll let you guys go to lunch early.